Hello, everybody. My name is not Mr. Minnick, but math is still my game. And before I hand the device, the remote, the microphone, that's what it is, over to Mr. Minnick, I have one question for you. How important must you be to be assassinated instead of murdered? Okay, I'm going to hand the remote, a microphone. I know it. I do. Over to Mr. Minnick now.
All right, thank you. Appreciate that. So Mr. Minnick is my name. Math is my game as well. Today with TI Topics, we're going to see how the TI-Nspire can help us. And you might notice I have the cast going right now. I was showing off a little bit, but so the cast will do some factoring. Maybe I better get the Nspire going, the non-cast going. So I'll go ahead and close my cast out to start up the Nspire. And what we're going to do is try to use our special eyes again and find the some special parts of quadratics. So let's look at our first example. Example 1, if we had y equals something like, okay, we're having a conflict of apps here. If we had y equals -2 times x minus 3, the quantity squared, plus 6, something like that. If you remember all the way back from chapter 4, that's a long time ago, I know. If we go all the way back to chapter 4, we should be able to pick out the vertex of that function in about 8 seconds or less. I'm hearing 3, 6. I like it. The x-coordinate is counterintuitive. The y-coordinate is not. The vertex has coordinates 3, 6. Something else that might be handy to find would be x-intercepts. X-intercepts. Maybe we want to find a y-intercept also. Okay, so x-intercept, y-intercept. Remember, an x-intercept is the value of x whenever y is 0, and a y-intercept is the value of y whenever x is 0. So it might be handy if we can graph a vertical and a horizontal line and find their intersections. I don't know, we'll see. So let's see. Y equals -2. Now, again, if I want to graph this, I see a lot of people using this scratch pad. The scratch pad is okay. I wouldn't recommend using it because it's limited in its abilities. So we're going to go to graphs. We're going to graph that function, -2 times the group x minus 3, the group squared plus 6. I said the group squared plus 6. The group squared plus 6. There we go. So this graph actually does, in fact, have x-intercepts, doesn't it? So maybe I want to go ahead and add that horizontal line when y equals 0. And to find my x-intercepts, then I'm going to go ahead and use my special eyes. I want the intersection point there and there. So there's my x-intercept. Oh. Couldn't we just use 0? Yes, yes, yes. So somebody noticed, hey, let's do this. Let's go doc. Insert from a calculator page. From a calculator page, there's got to be a way to find the zeros, the roots of a polynomial. You could do it on the graphs too? What? Oh, hold on a minute. Hold on. Menu, analyze graph, and a 0? Oh, I forgot about that. So we click there and click there. Oh, dang it. I just totally screwed that up. There it is. That's better. So we got the other 0 already then? So we didn't even need to do that horizontal line. Wow. Did it show both zeros instantaneously? Oh, okay. All right. So we got the 2 zeros. The problem is those are going to be irrational, and those are going to be decimal approximations, right? So, but it still gave them to us. I don't think that 4.331's right. So, yeah, something went awry there. So let me just undo all that. Okay. So menu, analyze graph, and find the 0. And it's asking the graph. Yeah, so it's this thing. Lower bound, I'll click to the left of it. Upper bound, I'll click to the right of it. So yeah, 4.73. There we go. Okay. All right. So that's that. What about our y-intercept? What are we going to have to do to see it? Change the window. So we'll go menu, window, maybe zoom out from down here. And now we could probably see it. What should I do to try to calculate that point? Table? Let's see the table. How do I get a table? Control T. So I'm looking for the value of y when x is 0. When, or did I say that right? 0, negative 12? There it is. Cool. 0, negative 12. Good. So our y-intercept is 0, negative 12. X-intercepts, there was 2 of them. So the only thing I guess that really kind of hurts us is when it comes to finding these things. That's not going to give us our exact answers, but it will give us decimal answers. Is that okay? Cool. So in example 2, what if we were asked to solve x squared equals 25? If we were asked to solve x squared equals 25, I think by now we're coming to love this nsolve, and we really do. It's awesome. nsolve x squared equals 25. Solve that for x, and we get 5. But that's only half the answer, isn't it? So perhaps a better thing to do would be to use this polynomial root finder. Find the roots of a polynomial. The degree is 2. Ax squared, a would be 1. The coefficient of x would be 0 if I put this in standard form, and the third coefficient here would be negative 25. Okay. So I guess there's a few drawbacks, but if I do that, I do find both roots. I do find both roots. Question. If I had plugged that in on the nsolve, the CAS still drops the ball and only gives you one answer on an nsolve. However, on the CAS, if I just do a solve as opposed to an nsolve, the CAS would say x equals 5 or x equals negative 5. Okay, great question about the difference between the two. Okay, so I guess that's really just about it. The only other thing I could think we might need to do is back on a graph page. If I wanted to get rid of my table, I hit Control T. If I had a standard form function, maybe finding the vertex. If I had something like x squared plus 2x take away 4, if I wanted to find the vertex of that, how would I find the vertex? Menu, analyze, and the minimum, click over here, click over there, and there you go. Okay. Any questions about using the TI-Nspire for the quadratics? Comments? Anybody have any ideas? If not, that's it. It's been real. It's been fun. I'll see you next time. Go.